Good afternoon, everyone. Thanks for joining today's webinar, Edge Computing, Gather, Analyze, and Communicate Roadway Data with MH Corbin. My name is Connor, and I'll be your moderator. Before we get going on today's webinar, just a few housekeeping things that I wanted to run through really quickly. All phone lines are muted. If you have any questions, please use the chat feature within your GoToWebinar toolbar. The presentation will last about 40 minutes or so, which will give us time for questions at the end. And by attending today's webinar, you are eligible to earn TARP points with IMSA. For those of you who provided your IMSA number during the registration process, Western Systems will go ahead and handle that submission for you. And lastly, today's webinar will be made available on demand. You can to view it, you can go to westernsystems-inc.com and find it there. All right, with the housekeeping out of the way, I'm excited to introduce today's presenters, Eldon Dienart, Sales Manager for MH Corbin, and Tony Brodnick, Territory Manager for Western Systems. Guys, the floor is yours.
Thank you, Connor, and good afternoon, everyone, and thank you all for joining this webinar. I'm Tony Brodnick, Technical Sales Rep for Western Systems out of Northern California. I believe many of you attending this webinar are familiar with Western Systems and that we sell and support innovative traffic solutions in California, Oregon, Washington, Idaho, and Montana. Now, this webinar will introduce some very innovative products from our newest partner, MH Corbin, headquartered out of Dublin, Ohio. MH Corbin provides ITS solutions that gather, analyze, and communicate vital roadway information in real time to help keep highways safe. With that said, I'm going to turn the meeting over to Eldon, Regional Sales Manager for MH Corbin. Eldon, take it away.
Good afternoon, guys. As Tony and Connor said, my name's Eldon Dienart. I'm with MH Corbin. I'm the Western Regional Sales dude for the company. And I'm excited, as well as Tony, actually, to actually be working with Western Systems again. I've worked with them in the past with other companies, and I really appreciate what they bring to the table, and I'm looking forward to future with them and in the state of California. That being said, MH Corbin is a company that was founded in 1986. Back then, it was really just another dealer distributor, and they dealt primarily in highway safety products, barrels, cones, that kind of thing. As far as clothing, anything that you guys see on the roadways normally that's orange or lime green, they did that kind of stuff. Excuse me. And then with time, we started to diversify a little bit and get into more of the ITS industry. MH Corbin bought out a couple of technologies, and we started to design, engineer, and manufacture devices and systems. And we do a variety of things, anywhere from an in-pavement sensor that's kind of like a puck, wireless in its transmission, to roadway controllers like we'll be talking about here today with the Connect ITS, and our primary go-to revenue source over the last many years has been highway advisory radio systems. So again, our newest product offering is indeed the Connect ITS. It's engineered to be a simple to use advanced roadside information system, or if you will, a roadside controller. Using data from a variety of sensors, algorithms compute the changing roadway conditions in real time, and that's roadway conditions that could be weather related or just traffic queue related, that kind of thing. Data is then sorted and distributed to your existing or new messaging network, and we'll get more into that as we go here. But pictured here on the left of the screen is the DIN rail version of the Connect. It's our most popular version. We actually have a 19-inch rack, which was the original product version. But once we had the 19-inch rack, everybody wanted to have a DIN rail version. And now that we have the DIN rail version, it seems to be more popular. It has more ports, more port density, and the form factor is what really attract people to the DIN rail / if you will, standalone version. So MH Corbin follows a basic architecture strategy in our designing and engineering products and solutions in the ITS market. Simply put, that is gather, analyze, and communicate. And we actually offer products in each group. In the gather, we have a product here in pavement conditioning called the VX21, and it is a wireless puck sensor. I kind of already mentioned that. It's embedded in the roadway. Some people like that. They definitely like the wireless aspect of it, but a lot of people don't like that. They want a non-invasive type of product solution. But anyway, that's an example of some of the things we do in the gather idea of things. In the analyze, that's where the connect resides, adding intelligence and logic to potential system solutions that we come across. And then communicate. We have flashing beacon controllers. We have the HAR that I mentioned a moment ago, and then we can definitely through the connect provide text and email alerting type of things. Another thing in the communicate realm of things, as far as messaging products, is they call it VSL, variable speed limits. That's an icon that wasn't included here, just FYI, I guess. Here are some examples of sensors and stuff that we use in the gather phase or the gather step of our architecture. Down here in the bottom right is our VX21. If you can see it well enough, there's a probe that goes kind of along the surface level. It's about 6 inches long, and that takes care of the surface temperatures. And then there's what we call a deep dive probe that goes down about somewhere between 16 and 20 inches and gets a better idea of how frozen, if you will, the pavement and the environment is in that area. Some things that you may or may not recognize, we already work very handily with Wavetronic side-fire radar as well as ISS side-fire radar. This claw-looking, crab-looking thing is a visibility sensor. This is an all-in-one ARWIS or remote weather information system sensor, and then you can, I'm sure, can recognize a couple of different types of cameras. In the analyze phase of things, that's where the connect resides. When we use Python as the script writing engine, it seems to be pretty well known in the industry. It's free. And I know a lot of consultants that I work with routinely. They've actually said that they require background in Python from any of their new hires. One consultant went so far as to tell me that many high schools these days are teaching Python as a what do you call them? An alternative, an elective. And then this script creation bullet point here, I only bring that up because we want to convey here that, excuse me, that MH Corbin does not insist on doing or controlling the script writing. We didn't create the Connect ITS product just so we could automatically start realizing additional revenues from engineering costs. So we'll go from absolutely nothing and say, here's your Connect ITS, take it, run with it as you see fit, or all the way up to providing a fully programmed and integrated Connect unit for your particular application. Anywhere in between. And then in Communicate, one last time, here are some examples of products that we integrate to already. We pretty much can integrate to any type of communications methods. DSRC or 5G has become a large focus for us at MH Corbin. Many agencies and DOTs around the nation have started to see that the Connect can be an integral part or portion of any DSRC deployment. Simply said, a lot of these, some of these agencies around the country, that is, if they install a DSRC radio, they will also want a Connect installed at the same location, at the same time, to add that logical control component to the communications in and out of that radio. As we grow with our relationship with Western Systems now, we hope to keep working with them and their Siemens DSRC radio and continue to move forward with that same type of idea, that same thought that's been introduced in a few places around the nation, to where it's a great thing to look at it as a combo. Excuse me again. A combo type of solution, the DSRC radio with the Connect, all in one little package, if you will. And here's the what I mentioned earlier: the variable speed limit signs, highway advisory radio. I mean, just really let your mind go crazy. Just about anything that you could see as a communications method. We probably do most of it now in the ITS world, but if we don't, if it's NTCIP compliant, it's a piece of cake to interface. If it's not, it's a matter of sharing resources from one manufacturer to us and that kind of thing. So moving on here, yeah, here's another view of the Connect, focusing on the variety of interface ports that we offer. I hope you can see that. Yeah, it's not bad. You can see that fairly well. The Connect, the DIN rail version is 6 inches by 5 inches by 3 inches, a real small form factor. A lot of Ethernet, hardened Ethernet switches these days aren't as small as this is. So that's why a lot of people in today's world with so much equipment in the cabinets, smaller is better. This just kind of shows you some of the interface connectors and connections that we have. So much so as we even have audio in and out. Not sure where that application actually came into being, but nevertheless, it's there. And I mean, I could envision something like a comms connection to sirens or audible alarms for something like a tsunami warning or something similar to that. And take note of the power requirements, anywhere from 10 to 36 volts DC. Only draws about 6 watts of power, and you can even utilize it via PoE if you're not aware or familiar with that. That's power over Ethernet if the application calls for it as well. Here's a handful of example applications that the Connect has fit well into, that we have worked with. Yeah, these are all examples that we've worked with, including this rollover truck warning. That was something up in the Northeast states, and it's just listed there. I actually don't know what that actually pertains to, but you can see a lot of other things here that are weather related, icing, pavement conditions, low visibility, high wind. high water, that kind of thing. But again, the R stands for rural or remote weather information systems. And but with the course of time, we started to develop more and more within the true ITS industry applications. And again, these are just examples. Your mind, that's the only thing that's limiting you for particular applications that may work specifically for you and your agencies. So now I want to move into just a few application examples for you, specifically that are connect related and specifically that we have deployed out in the nation. This first one is with New Mexico DOT. We call it, well, they actually call it the Dust Warning Project, as noted here. And this is part of my territory covering the western states, and I really appreciate this application because it really shows the versatility of the Connect. And as we get into a couple more slides here, you'll see that too, hopefully. But anyway, a few years ago now, in the summer of 2017, a dust storm developed over a part of Interstate 10, I-10, in the southwest portion of the state as you come across from Arizona into New Mexico. The lay of the land, so to speak, was just totally conducive to this dust storm potential. And as it says here on the screen, this is actually a real picture that came from that event, and there are all sorts of fender benders and stuff like that. But the critical factor is that it resulted in 6 deaths, and then within 2 days, 48 hours, they had another dust storm, and it resulted in 2 more deaths. So the idea was there that both the New Mexico government and the DOT they felt like they really had to do something to rectify that. And then in conjunction with that summer of 2017, within 2 or 3 months of that time, ITS New Mexico had their annual conference. It's a one-day conference they have in Albuquerque, and we were fortunate enough to be presenting at that conference. And the DOT was really turned on by us being able to have the Connect. They appreciated the offering. They appreciated what the product could do. And yeah, okay, this is the layout of that area of the country. You'll see here that this is the dry lake bed right in the middle of the picture. And then over here to the left there's a dotted line here, but that's the Arizona border, and up in the far right upper corner here is the closest town, Lordsburg, New Mexico. A few things I want to point out is the green rectangles or the green squares are RWIS locations. There's about 5 of them in this project. I think there were 2 or 3 that were pre-existing to the actual application solution, and then the couple more were added in. The stars here, the red stars, are DMS, VMS locations, and there's 2 or 3 on the overall route. And then moving on, the yellow circles are indicative of flashing beacons, and the flashing beacons are on static signs that basically say you're entering a wind corridor or a weather corridor. And then lastly, not lastly, but these 4 blue triangles they represent variable speed limit signs, and they are literally located about 0.2 of a mile from each other in order, and that's to hopefully get the speeds to gradually slow down. So there's 2 sets of them, one for eastbound and one for westbound. Now, lastly, this green pentagon up here is the local cabinet where the Connect ITS unit resides. And this whole corridor is about, well, I could show, it's about 17.5 miles, and it's all on fiber. It's a self-contained fiber system, if you will, because it's not directly connected to the rest of the state DOT fiber system, at least not yet. And so the Connect can communicate very well to any and all of the devices because of that nice fiber backbone. Yeah, let's move on. Here's the actual, excuse me, system application block diagram that MH Corbin came up with to assist in the overall product solution. Both the DOT and MH Corbin shared information and came up with this overall solution as far as the block diagram. You'll see here, first of all, that I highlighted the different thresholds that are involved in this project, and over here I'll explain that a little bit more. It's actually from bottom to top as the block diagram goes, and the bottom would be totally normal, clean, crisp conditions, no winds, no dust, that kind of thing. And as you can see here, none of the communication devices are on or displaying anything at that point. The first threshold is related to winds. If the winds become more than 30 miles an hour, then they turn on the DMS signs with this particular message, slow down. The flashing beacons on those static signs come on, and the VSLs get posted at 65. The normal speed limit through that area is 75. And so the speed limit, the VSLs are trying to bring them down, bring the traffic speeds down just a little bit. But at that point, you know, things are still okay. But it's a transition, it's a threshold that the DOT wanted to deploy in these types of situations. And from that point on, all the rest of the thresholds have to do with visibility, starting at 1,000 feet and working its way down where the worst case is 400 feet visibility. And, you know, the powers that be determined that less than 400 feet is a situation where you cannot see very far, you cannot see very well at all. So anyway, as these progressions increase, you'll notice over here with the next set, like that, again are decreased from 65 as you go 0.8. And the scenario that out of as well is supposedly no visibility. The speed limit becomes 0. Stop, pull off the way. This sign is rather elaborate at that. It really is a two scenario, and this is continuing on that idea of how to program the overall solution. And I don't know if you can see this, but right here it says no visibility, pull off the road, feet off the brakes, stay buckled, and wait till clear. And that's a very key element at that point of the storm if you really can't see, because oh, this is locking up on me again. There we go. Sorry. Yeah, with the first 4 slots having to do with just slowing the speeds down, that last slot of or last message coming out of the DMS, no visibility, pull off the road, feet off the brakes, stay buckled, wait until clear. It's actually a 2-page message, but think about it for a second. If you actually have your lights on or your foot on the brakes and you're pulled off the side of the road, the people behind you will very probably be tracking on whatever they can see. And if they see their lights, they're going to track your lights, they're going to track on your lights, and all of a sudden you have another collision. Anyway, that's the gist of the dust storm application. But a couple things I want to add is that the New Mexico DOT was very key on our solution because of its flexibility and just as much for its automated nature. I showed you, I'll go back 2 screens here. This, the layout of the network, the remote network. Up here, they have, up here at the node cabinet, they have the ability to either a landline or microwave or both to connect back to the next piece of fiber or all the way to the Albuquerque TOC. But they don't want to have to count on that comms link being, 100%. I mean, obviously they want it to be, but they don't dwell on it. If something is amiss with that, then they have confidence that the system is still operational and doing its thing as it should do its thing, completely automated and remote. So those 2 items, the flexibility in setting multiple thresholds and the automated nature of the solution, is really what fired up the DOT about that application. And it's been up and operating now for, yeah, a good year now. Oh yeah, that's right. Sorry. Moving on to the next application example. It's for Nevada DOT. They call it the high wind warning, and it's actually for, more specifically, for District 2, which is northwest Nevada, including the greater metro area of Reno, Sparks, Carson City, that kind of thing. I think they go up to Lake Tahoe as well, but key to this example and key to most ITS examples is in this metro area for them. Let's see here, where was I? Yeah, the Washoe Valley is right here. This is Carson City, and then Reno is a little bit up further north of this pictured overhead view. And just because, again, of the lay of the land with the mountains over here and Lake Tahoe is way over here somewhere, just because of things, they get some really gusty winds shooting through there, and they wanted to be able to alert the media, so to speak. They wanted to let the traveling public know what was happening, so they weren't just like blown off the road, so to speak, especially truckers, especially the truckers. They wanted to warn for the advent of strong winds. They wanted to do it in real time and automatically, and they wanted to communicate the strength of those winds as part of the thresholds to the public as well. Once again, especially the trucking industry. the heavier the winds, the more they would react as maybe pulling off and just waiting for a while, that kind of thing. So here's a similar logic diagram for what we did. And over here is the progressive thresholds, once again, gusts over 40, 50, 60, 70, and 80 miles an hour. But all at the same time, if you look really close at this logic diagram, we have an and/or type scenario. If the winds are strong, and I don't know how well you can see this, but that little block says if the temperatures are less than 35 degrees and the surface is quote unquote not dry, then they would post the winds, and they would also post winter driving conditions as a kind of like a 2-page solution again. If there wasn't winter driving conditions and just the high winds, then they would go with these 4 thresholds. And I'm sorry, 5 thresholds. The winds, they would post those wind gusts and keep them posted. As soon as they got a wind gust, they would keep it posted for 20 to 30 minutes unless they got a higher wind gust. Then they would change. Then they would change the signs accordingly. So let's see, moving on. Okay, to my last example, and getting towards the end of my presentation, is wrong-way driver detection solutions. This is a kind of a high-level schematic view of what MH Corbin looks at and thinks about as we look at a wrong-way detection scenario. There's a lot of parameters involved, or a lot of parameters that can be involved depending on the actual application. The wrong-way driver detection application is something that's become more and more important as a system solution to a lot of agencies, primarily DOTs, and primarily in conjunction with their off-on ramps. The key factor for interested agencies seem to be the potential for head-on collisions, because with a head-on collision, there's a high percentage in this type of collision that results in death. So it's something that's has become very important to different departments in different agencies. That's why we've been spending some time with it. So here is a pictorial, I'll say, of a typical application that we developed early on. And the way we looked at it is having 2 distinct detection modes. In this case, this could be LiDAR or side-fire radar. Camera could be a second detection. And we felt that if you have that secondary detection, it confirms, it can be something that confirms the reality of a wrong-way scenario developing. There are a lot of potentials for false calls, false positives in the wrong-way environment. So that's why we started to develop in this scenario with 2 detections, 1 to detect and 1 to confirm. And we didn't, at the time, we didn't care whether you led with the camera detection and followed it with radar or LiDAR. That was more up to the agency and what they felt best in looking at it. I can go a little bit more detail if you want later on, but I just wanted to show you this scenario and see where we go with it. Oh, I'll explain the rest of this. Here's a DMS up on the freeway lanes. We're depicting the DSRC or 5G as well as a messaging method along with the DMS. And then here is a final messaging view, if you will, or option as far as sending emails and texts and stuff like that to the TMC, to the maintenance group, to the management group, et cetera, et cetera. So rolling the camera, here's a good driver going the right direction from left to right. Conditions are good, nothing happens. Then you get a wrong way driver coming in, and he gets initially detected by the LiDAR, radar, what have you, by that first detection. And at that point, it's a warning. Depending on what you as the agency would want to do, you could actually send that warning through the system and have it come up on the DMS as a more of a warning type scenario message, or maybe at that point, maybe it would be just text messaging and that kind of thing to alert the TOC operators and have them take a closer look. But then, if in our system, if the camera in this case gave the confirmation detection, then we would go into a true alert mode. And at that point, the wrong way signs would engage, the messaging signs on the DMS would engage, a TIM message would be a broadcast out of the DSRC or 5G. TIM in this case stands for Traveler Information Message, and that could be something very similar to what's posted on the DMS, or it could be even a little bit more elaborate, because you'd be seeing that on a onboard unit or on your screen in your vehicle, to where there's more room to write, so to speak. And then moving on, email messages would be sent, and then ultimately the true goal is to have that next oncoming car get out of the way of the wrong way driver. So that's a figurative way that we have looked at this, and now I want to show you an actual application that has a little wrinkle on that, but very close to what we're discussing here. And that's this application is for the North Carolina Turnpike Authority, or NCTA, and the next few slides are totally involved with this as far as a pilot test that was done on one. I have no idea how North Carolina is laid out, but on one of their off-on ramps, you can actually see it over here to the right. This is the actual off ramp, and this is the on ramp, and it's confused into this. As it states on the slide, it was just very recent. NCTA and DOT on site for this, and I have no idea where NCTA is. It's outside of North Carolina. Where let's see, moving on, I think is something else I wanted to say. In this particular application, we are using LiDAR as the primary detection solution. Here's a picture of that actual ramp area. This is the LiDAR unit. This is a Bosch high-end intelligent camera, and then this is actually a fixed camera up here. But in regards to LiDAR, I don't know about you guys, but I didn't really know about LiDAR until like anywhere from 4 to 6 months ago, and I'm still learning all about it. LiDAR is another acronym like radar, but in this case, it has two definitions to very similar. One might be light detection and ranging, and the other one can be laser imaging detection and ranging. And in any event, LiDAR is a method for measuring distances and ranging by illuminating the target with laser light and measuring the reflection with a sensor. differences in laser return times and wavelengths can then be used to make a digital 3D representation of the target zone. So, yeah, LiDAR detection of the wrong way. And the camera, again, this is a Bosch camera. We have an ongoing relationship with them. We've done a lot of testing with them, and so now we're trying to share technologies through them and them through us, both. And the this particular camera has a lot of analytics built in to make it a smart thing to where we can actually use that camera for tracking the vehicle. And then, of course, the Connect. Okay, let me see here. This slide actually kind of speaks for itself. We did a variety of different tests using different types of vehicles, cars, trucks, motorcycles, a variety of speeds. A multitude of tests were done, and it actually included situations from the end users where they specifically tried to trick or outsmart the system in a way to force a false positive reading. But through it all, even with them trying to mess with the system and throw it into a false alarm scenario, the results of this test was 100% accuracy. And obviously that means no false positive detections. A couple of things that the agencies were really impressed with is everybody was on site during this test, and text messages were being sent out, emails were being sent out to specific email addresses and phones, and these were happening almost instantaneously. Text messages 1 to 3 seconds after detection, and the emails were coming shortly thereafter, anywhere from 5 to looks like 30 seconds. And they also have, we also have a cloud dashboard involved with this particular application, and it updated within 90 seconds. Now, this guy, almost done with the presentation here, this guy is an example of an email that would go out. And the basic message is a wrong-way vehicle has been detected at such and such. And within the email, you can actually view a live video feed, and attached to the email is a JPEG picture, a still picture of the detected vehicle. And then over here is just an example of the actual text messaging type scenario too. Saying basically the same thing, wrong way vehicle detected at such and such. In this case, it's at exit 62 of that particular highway in North Carolina. So all that being said, I guess that I am literally done, and I wanted to thank you for putting up with me. I hesitated here and there from time to time, stuttered, but that's just part of my personality. And with that said, I'm going to hand it back over to Connor and see about any questions that any of you guys might have.
Great, thanks, Eldon. We'll get going on the Q&A process. So please use the chat feature within your GoToWebinar toolbar there to ask any you may have. But Eldon, we did have, looks like a handful come in while you were speaking, so we can just go ahead and dive right into those. And the first one is from Jack, and Jack asks, what is the cost of the Connect ITS?
Simple put, our upper management wanted to be like a used car salesman and be able to say that the unit was less than $5,000 base price. And so it's $49.95 list price. Gives you $5 of room before you get to that 5K level. And there are some options involved if your application's actually called for a built-in modem. Most agencies these days have their own qualified parts list and products list, that kind of thing, as far as what type of cellular modem they would use. And so typically that's a moot point, but if it's not, then we could offer a cell phone option, and that's why it's an option, because most people actually wouldn't use it.
Great. Next question for you is, does the MHC require that they themselves do any or all scripting?
I kind of mentioned that earlier on in the presentation, but no, we can. There'll be a scripting library of a sort that we're still developing actually at this moment, to where you can pick and choose different scenarios, different scripts that have been used already somewhere else in the country, and it just becomes a part of our library. And typically those, let's say it was the dust storm thing, and you were trying to track wind speeds of one sort or another. Maybe your threshold would be 45 miles an hour, and in that particular example for the dust storm application, it was 30 miles an hour. So you could go in to the script and pretty easily adjust that and change some of those parameters. And you could also get a little bit of that kind of support from our engineering staff. But again, you could do everything on your own, or we could do bits and pieces for you, and anywhere in between. When it comes to the actual labor rate for engineering for doing these types of things, if it like the Nevada DOT application was a little trickier because we were putting that and/or threshold in there for potential winter weather, as well as posting a given message for 20 to 30 minutes. That was something that was just a little wrinkle added by Nevada DOT, and because of that, we had some engineering time that they didn't want to do it. So we literally just charged them. I think our going rate for engineering is $200 an hour, but it was very minimal. It only took a few hours of time, and if something like that is in the works, as far as an overall application, we would typically work out those details with the agency ahead of time and negotiate and/or quote the system solution with that additional engineering time worked in. So in the case again of NDOT, for instance, their solution for our connect and engineering time cost them less than $6,000 because we did the connect at the list price of less than $5,000, and we either added 4 or 5 hours of engineering time, and that's still rather affordable. You know, all you guys that may have consulting backgrounds and that kind of thing, you know, it's an expensive venture. Again, just to say, we're not out there to make a lot of money on engineering time. Thanks.
Great. That looks like all the questions that we got. So thank you, Eldon and Tony, and thank you everyone for joining today's webinar, and have a great afternoon.
Thank you all.